Okay, for problem 5 here, what we're given is a set of x and y coordinates that generate a linear rule, which means that if we plotted these points out on a graph, kind of like the little one you see here, if we plotted them out and drew a line between them, it would make a straight line. And that can be done through a linear equation. So that's what we need to do, is find the equation. For each set of coordinates, write the equation that describes the rule. This is just like what we've been doing in class for warm-ups. So what I did was I took this first set for A, this first set of coordinates, and I put it into a table. So there's x and y, and I put them into the table x and y like this, so that I could see it a lot easier and notice what the patterns are. And if we remember in class, our first step is to figure out how much y increases by when x increases by 1. So if we look at this, so let's look at the distance between our y's every time x increases by 1. So there's x increasing by 1 here, and the distance between -7 and -3 is 4. And x increases by 1 here, and the distance between -3 and 1 is 4. And x increases by 1 there is 4. So x is multiplied by 4. Somehow it's increasing by 4. So if you'll remember, we'll start off our equation by just simply saying 4x. 4 is multiplied by x. Now, that's a horrible x. Gotta make a better x. There we go. That's a much better x. Now we go to the next step and figure out if x is 4. In other words, if we have x is 1 times 4, how big of a distance is there between 4 and the result y, which is 1? We know that the distance is 3, but to get from 4 to 1, we would have to subtract 3. And that's our equation. Any one of these numbers you put in there, you're going to get the resulting x. So or the resulting y. For example, if we put 5 into this and go 4 times 5 minus 3 is going to give us 20 minus 3, which equals 17, which is what we've got right here. This is our equation, and remember, this is what we've been doing for quite a while in warm-ups for class.